Hi everyone, myself Dr. M. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering. So in this video, I'm going to discuss about what are the various definitions and terminologies that are involved in designing the tables and graphs for data presentations. So the very first question is that what is data presentation? So the data presentation is nothing but is the one of the way of method in which the people is going to be organized or summarize or communicate the information using a variety of tools such as tables, graphs and diagrams, right? So what is the data presentation is nothing but is one of the way of method where the people can able to organize or summarize and communicate the information using the variety of tools such like tables, right, and then graphs and diagrams. The next one is that what are the different types of data presentations we are having. So the answer is that the presentation of data should be classified into two types. So first one is the tabular presentation and second one is the visual presentation. Again, this visual presentation is going to be divided into two further categories, that is graphical presentation and diagrammatical presentation. These are the different types of data presentations what we are having. And next question is that what are the uses of data presentation? So the uses of data presentation will be easy and then better understanding of the subject, and which one able to provide the first hand information about the data and helpful in future analysis and easy for making comparisons and very attractive. So these are the some of the uses of this presentation. So first one is that easy, and second one is that better understanding of the subject. So through the presentation what we can able to clearly understand what the subject is, and then which can also provide first hand information about the data and also helpful in the future analysis and for easy for making comparisons and then very attractive. So these are the some of the uses of the data presentation. And what are the principles of data presentation? So the principles of data presentation will be, so the data should be presented in simpler form. Okay, whatever the data we're having, that should be presented in simple form, and then which can also arouse some interest in reader. So what is the data we're presenting, that should create some interest in the reader, and it should be concise, okay, without losing the important details. So what is the data we are concising? So we should not lose its important details, and we should also facilitate the further statistical analysis, and then we should also define problem and should suggest its solution. So these are the some of the principles of the data presentations. Okay, so the data presentation means the data should be presented in simple form, which can also create some interest in reader, and should also be concise without loading important details and facilitate the further statistical analysis, and we should also define the problem and then suggest its solution. And next one is that what is tabulation? So tabulation is nothing but is a systematic and logical arrangement of the classified data. So either in the form of rows and then columns, that is called as tabulation. Okay, so tabulation is nothing but the systematic or logical representation or classification of the data into rows and columns. So let me take a table like sport, and then people as the other column. So where the sports like snooker, tennis, gymnastics, swimming and track, there should be the sports category, and how many number of people are going to participate in each category. That should be like this. I can able to construct the tabulation. And next one, what is the significance of data presentation? So the significance of data presentation will be which simplifies the complex data. So what is the data we're having in the form of text? If you are going to represent in the form of tables, so what will happen means, so what is the data we are having, so that should be looks very clearly and easily understood by the person or the user who are going to deal this. Okay, so that should be the one of the significance, and then unnecessary details and repetitions of the data could be avoided in tabulation, and then facilitates the comparison and also gives identity to data, and then we should also reveals the pattern with the figures which cannot be seen in the narrative form. Okay, so the significance of the tabulation will be simplifies the complex data, and unnecessary details and repetitions of the data should be avoided in tabulation, and then facilitate the comparison gives identity some data, and then reveals the pattern within which the figures cannot be seen in the narrative form. And next question is that what are the different types of tables? Okay, so just now I said what are the different types of presentation. So within that, tables is the one of the category, and then what are the different types of tables will be is, so based on the purpose, the tables are classified in two types, like reference tables and text tables. And based on the content, what we have to say is the first one is simplex tables, and then complex tables. Again, this complex table is further divided into double table, triple table, and multiple table. So these are the sum of the different types of tables. Okay, so the tables are classified based on purpose and based on the content. Based on the purpose means reference table and text tables, and based on the content means simple table and complex table. And what are the different types of complex tables means double table, triple table, and then multiple table. Next, so what is a reference table? So reference table is nothing but what we can able to call it as general purpose table and then primary table. And these tables are going to present the original data for different purposes. So it contains only the absolute and actual figures, and around the number of percentages. Okay, so the tables what we are having, so that should be normally you can able to call as general purpose or primary tables, and these primary tables can able to present the original data for future purposes, reference purposes. So normally this contains only absolute and actual figures, and round numbers or percentages, that thing. Next one is what is a text table. So text table is nothing but a special purpose or a derivative tables. Okay, so these tables are going to be constructed by presenting the selected data from one or more than one or more general purpose tables. Okay, so the tables what I am having, so that should be simple. If you are going to represent to more than one general purpose table, then it should be called as special purpose or derivative tables. And then it should also brings out some specific point of answer to a specific question, and it also includes ratios, percentages, and averages, etc. And it should be found in the body of the text. So this is the example what I am showing in right side. That should be the example of special purpose or derivative tables. Next, so simple tables. So simple tables looks only going to represent only one characteristic. Suppose that is a gender. So gender is maybe boys and girls. So that should be simple table. Suppose more than two characteristics. Suppose gender and food habit. I want to represent it. So again, this food habit should be vegetarians and non-vegetarians who can able to eat. Represent more than two. So this is one characteristic and the characteristic. Right? That should be double table. And then triple table means more than two, and that means three. If we are going to show the characteristic, then it should be triple table. So first is gender, and food habit, and age is the other thing. So these three characteristics, if you want to represent, then you have to go for the triple table. And multiple table. So multiple table means more than three. That should be one able to call it as multiple table. So gender is one characteristic, and food habit is another characteristics. So age is another characteristic what I am showing, and then what is the area, residing area is the another characteristic. So if I want to show like this, then I have to go for the multiple table. Okay, so the multiple table should be more than four characteristic, then it should be go for the multiple table. Okay, so these are the some of the different categories of tables. Simple table, double table means we can able to show two characteristics, and triple table means only three characteristics we are able to represent, and multiple means more than three, that should be considered as multiple tables. And next thing, what are the advantages of graphs here? So the advantage of graph should be there attractive, and then it should also give some bird's eye view of the data, and it should be easily understood by common men, and it should also facilitate some comparison of various characteristics, and impression is going to be created by them or long lasting, and theorem and results statistic can be visualized using graphs. Okay, these are some of the advantages of the graphs. Okay, so attractive, and then bird's eye view of the data, and can be easily understood by the common man, and we should also facilitate that common characteristics or common comparison of various characteristics, and then should be created by long lasting, and then the theorem should also and results of statistics can also be visualized using graphs. So these are the various advantages of the graphs. And next question is that what are the limitations of graphs? So limitations are these graphs are usually visualized, so that what will happen is they cannot be considered alternatives for the numerical data, and though theorems and results should be or could be easily visualized by diagrams and graphs, so the mathematical rigor cannot be brought in, and the diagrams and graphs are not accurate as tabular data. Only the tabular data can be used for the further analysis, and another limitation is that by diagrammatic and graphical misrepresentation, the observers can be misled easily. So it is the only possible to create the wrong impressions using the diagrams and graphs. Okay, so the limitation should be they are not considered alternative representation. That is one of the limitation, and the theorems and the results should be easily visualized, but they cannot be brought in, and the diagrams and graphs are not accurate as the tabular data. Only the tabular data can be used for further analysis. Next, so what are the rules for drawing graphs and diagrams? So first thing is that first we have to choose the form of the diagrams or graphs which is capable of representing the given set of the data. So that is the first thing you have to identify. After then we have to choose the title. So what is the title should be is it should be used the brief information about the diagrams or the graphs what it contain, and then the scale. The selection of scale should also be important. Either it should not be too small and neither should not be too large. And neatness is under rules what have to be considered and attractive. So what the different types of lines and shades are available, right? So but that can be used to make the pictures very attractive. And originality. So originality should also helps the observer to see the details with accuracy, and simplicity is another one. So where is going to show the good diagram depends upon the easy within which the observer can interpret it, and economy, the cost and labor should be exercised by drawing the diagram. So these are the some of the rules for drawing the graphs and then diagrams. And next one is what are the differences between the graphs and diagrams is another question. So for that what should we do is, so we have to construct a graph. Or graph is generally going to be used, whereas diagram is going to be constructed based on the plain paper. And if I'm going to take a graph, so the graph should represent the mathematical relationship between the two variables, whereas the diagram does not. And the graphs are more appropriate than diagrams to represent the frequency distribution time series. And the diagrams are more attractive to the eyes, such as better suited for publicity and then propaganda. And the diagrams cannot add anything to meaning of the data, and hence they are not helpful analysis of the data. And the graphs are very much used by the statisticians and research workers in their analysis, right? The first thing is that we have to construct a paper or graph paper. Well, that one is needed, but whereas diagram plain paper is sufficient. So the graph represents the mathematical relationship between the two variables, whereas the graphs are also more appropriate to represent the frequency distribution time series. And the diagrams are more attractive to the eyes and also best suited for the publicity and propaganda. Next question is that what are the different types of graphs and diagrams? So the graphs will be of different types like histogram and then frequency polygon, frequency curve, and then Ogilvy's line graphs. Whereas diagrams should be of two types, bar diagram and pie diagram. So again, this bar diagram is further divided into different categories like simple diagram and then multiple bar diagram, component bar diagram, uh, percentage bar diagram, and deviation bar diagram. So these are some of the examples of the diagrams what we are having. Then what is a histogram? So histogram is nothing but it should be represented by set of rectangular bars, and then variables is taken along the x-axis and frequency is going to be taken y axis. So with the class intervals as the base, the rectangle with height proportional to the class are going to be drawn, and the set of rectangular bars so often use the histogram. Okay. So the histogram is going to be constructed by making use of rectangular bars, where the variables are going to take on x-axis and frequency is going to be taken on y-axis. So example how to construct a histogram. So let me take height as one column, so 45 to 150 the class interval, and 150 to 150 and the class interval. So like this, I have to take the class interval and frequency, how many number of times are available. The frequency is going to be identified by using this. We have to construct the histogram. So in x-axis, I have to take the class intervals what I am having, and the frequency is going to be taken on y-axis. So 150 to 140, 145 to 150. Sorry. So that one is 2. So 145, how much it is? Frequency is 2. And next one is 5. Next one is 9. Again 160 to 165 is 9. And 4 and then like this I have to construct the histogram without taking any gaps between the bars. And the mode of distribution can be obtained from the histogram like this. So the middle what I am going to get, that should be the mode of frequency distribution. And the frequency curve. So frequency curve, what is the frequency curve is the question. So the variables that is taken along the x-axis and frequencies are going to be taken on y-axis similar to the histogram, and these frequencies are going to be plotted again the class mid intervals where these points are going to be joined by the smooth curve. Okay, the curve so often we can able to call it as a frequency curve. So the total area and the frequency represent the total frequency curve. So normally when you are having this type of graphs actually, right? So the midpoints what I join the rectangle points, so the curve what I am going to get, that should be the frequency curve. Let's see the example here. So this is the graph what I obtained. Suppose it will be a previous histogram. So the midpoints of this rectangular bars, if I'm going to join it by a smooth curve, that should be able to call it as a frequency curve. Frequency polygon. What is frequency polygon here? So here the variables are going to be taken on x-axis and frequencies are going to be taken on y-axis. The class frequency is going to be plotted again the class mid values, and these points are going to be joined by a straight line here. So if we take, this should be the free curve. So if I'm going to join through a straight line here, then it should be able to call it as frequency polygon, right? So the frequency polygons, all the points, all the midpoints of this rectangle bars are going to be joined by a straight line. That should be the frequency polygon. See the example. So this is one class interval and this is another class intervals I'm taking. If I'm going to see this table and number of workers in this salary, and this is the points what I initially have. So if I'm going to join this dots what I am having through a line, then it should be frequency polygon. And next one is that ogives. So what is an ogive? So otherwise other name of ogives is that cumulative frequency curve. So ogive is the smooth graph with the cumulative frequency plotted against the values of the variable. So that is class limits, and these class limits are going to be taken along the x-axis and CF on the y-axis. There are two types of ogives. So less than CF curve or less than ogive, what we can able to call as one thing, and greater than CS curve or greater than ogive, what we can able to call as another type of frequency. Okay, less than CF cumulative frequency, and second type of cumulative frequency is greater than cumulative frequency. So these are the two types of ogives what we're having. So what is an ogive? So ogive is nothing but less than cumulative frequency. So the variable values is taken on x-axis and CF are going to be taken on y-axis. So that is less than CF are going to be plotted against the representative variable values, and these points are going to be joined by smooth curve. Resulting graph is nothing but ogive, and the variable values are going to be taken along the x-axis and the CF is going to be taken along y-axis, and this CF is going to be plotted again the represented variable values, and this one is going to be result is greater than ogive. Like this, we are having two types of ogives, so less than curve and greater than cumulative frequency curve, positive and the negative ogives. So see this one should be the less than ogive values, and this one should be the greater than ogee values. So the intersection of these 2 points should be the what we can able to call it as the ogee point. Okay, so this one is less than ogee point, and this one should be positive greater than ogee point. Then how are we going to calculate this median from the ogee? So the intersection point of these two ogees, that is less than ogee this one and greater than ogee this one. So this one should be the median value of the ogee center point. So next one is line graph. So what is the line graph? So this one is also otherwise able to call it as the time series graph. Okay. So the line graphs are going to be used to display the comparison between the two variables, which are plotted against the x-axis and y-axis. And the x-axis are going to be represent the measures of time, while the y-axis is going to represent the percentages or the measures of the quantity. So they organize and present data in clear manner and shows the relationship between the data. The line graph displays a change in direction, and it also shows a trend of event occurring over a period of time to know whether it is increased or decreased. Okay, so the line graph or time series graph. Okay, so this line graph, so what the dots were going to be plotted on the x and y axis. So after joining all these line points with a line, so that should be able to call it as the line graph. And the organizer present the manner very clear manner shows the relationship between the data, and line graph is going to display the change information into direction. See the example here. So this is the plotted values initially. So what are the plotted values I'm taking here? So if I'm going to join with a line, that should be able to call it as a line graph. So here foreign is going to be taken on x-axis and duration of admission going to be on y-axis. And next one is the pie diagram. So pie diagram, otherwise you can able to call it as sector diagram. This pie diagram represents the discrete data of qualitative characteristics such as blood groups or RH factor, age group, sex group, and causes of mortality or social group in the population. And these frequencies of the groups are going to be shown in the form of circle, and the degree of angle denote the frequency and area of the sector, and it should also give the comparative difference at glance, and the size of each angle is going to be calculated multiplying the frequency by total frequency. So the size of angle is going to be measured by frequency by total frequency into 360 degrees. That is the size of the angle can able to get it. Okay. So the pie diagram is going to show the discrete data of qualitative characteristics, and the frequencies of these groups are shown in the form of circle, where the degree is going to be obtained by the frequency and area of the sector, and it also gives the comparative difference at the glance. That is the advantage of this pie diagram. Look at this. So first we have to construct a circle here, draw the circle and find the center point of the circle and draw the radius, and then use the protractor to find the angles, how much it is. So if you suppose if it is 35% and then 25% and then 45%, 55 like this. So the entire round should be equal to 100%, right? So see the example on the left hand side. What is the distribution phase is 62% and roof percentage, board percentage, 6% and transportation. So these are some of the examples how to construct the polygon. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.